Hello everyone, hope you guys are all doing well in this lockdown situation. So today, right now the May challenge in LeetCode is happening. So I have been doing all the problems in the May challenge. So today's problem is single element in a sorted array. So I found this problem very interesting. So that's why I think I should be showing you how to solve this problem. So let's go through what the problem statement says. You are given a sorted and consecuting sorted array consisting of only integers where every element appears exactly twice except one element which appears exactly once. Find the single element appearing only once. So this problem is similar to what actually there were in the April challenge also, where we have to just go through whole list and we have to sort the elements and we will find the single occurring element. But here one catch is it is first of all saying the array is sorted. Okay, and here it is also saying that uh, the time complexity of our code should be order of logn. So for the XOR method where we are going through the whole array and XORing the elements, there it would be order of n. So it will be a time limit exceeded for our solution. So we have to do it faster. So just because this is a sorted array, we can do one thing. We can use binary search in this problem. So let's see how we can use binary search. So now let's look at how to solve this problem. So let me bring up my notepad over here. So you can see that I have written down the first example over here, and these are the indexes or indices of all the elements, like 1 of 0, this one is of index 1, 2 and so on. So we have to find the element which is occurring only once in this list or array. So the element over here for this example is 2. So first let's just observe one thing. Before the single element is occurring, the pairs which are having same value, the first element of the pair is always at the even index. Like here it is even index, so let me write it down as E, and the second one is at odd index, so let me write it down as O. So this trend we can observe before the single element occurs. All the pairs which are before the single element, always in that pair first element will be at even index and second element will be at odd index. As you can see, 0 at 0 there is the first element of the pair, at 1 which is an odd index where we are having 1. So after this element occurs, all the pairs which are after that will be, the first element would be at odd index and the second element would be at even index. Just the reverse of this, as we can see here. The first occurrence of 3 is at odd index and second occurrence of 3 is at even index. So this is why important. This is very important. Why? Because when we are doing the binary search, so we have to have some condition, like here we are having 8 elements. So what would be the middle element? It would be 4. So at 4 we are having 3. So now at 3 we have to check that if the next element of 3 is same as 3 or not. 3, first of all, the middle element over here is an even index. So according to this condition, if the at even index the element is same as the next index, which is an odd index, then this means what? This pair exists before the single element occurring. But in this case this is not happening, because at 4, which is an even index, there is 3, and after that at 5, which is an odd index, it is having 4. So these two are not same. So that means what? The single element occurs before this. So we have to make our end pointer to pointing to this point. So that's why if our middle was here, we have to point it to this position. So that means what? The pointer which was pointing initially to here, which was called mid, it has to be now pointing, the end pointer has to be pointed to mid minus 2, which is this. So now again this length is 3. So what is the middle of this element? Again we have to check if the index of this element is even or odd. It is odd. So we have to check if the element before that is even same as this element or not. So the element before this is same as this element, so that's why these two pair exist just before the single occurring element. So we have to check from the right side of it. So that's why when this was middle, so we have to check from middle plus 1. So that's why from here. So now here the left index and right index are converging, that's why this is our answer. So just like traditional binary search, and we have to just understand the bounding functions because here it is a bit tricky. So that's why these two things are coming in handy for us. If this pair satisfies, that means what? The element is after that, and if this pair satisfies, this means the single occurring element is before that. So this is quite self-explanatory, I think. So if you look at the code, it will be more helpful. So let's look at the code. So over here I have written down the code. So first of all I am doing some error checking. If it is an empty list, then we are throwing returning a -1, that means it's invalid. After that we are defining a function called fun. It will be a recursive function like we used to have in binary search. First of all, the base conditions are like if the left bound is greater than the right bound, then simply return. If the left is equals to right, that means what? We found the element at that index, so we can return nums of L or R, similar thing. Now we are calculating the mid position, which is basically left plus right by 2, and we are doing this way because just to avoid any overflow. And after that we are having this condition. Let's suppose we are having one example like this, where 1, 2, 1. Here the middle element itself is the element which is occurring 1. So we have to check left of it and right of it. If the left and right both are different from this element, that means this is our answer. So that's what I am checking over here in this line. So after that we are checking if mid is even or odd. Like here we were checking if mid is even or odd. So after checking, we are checking if the element at that index is similar to the next element or not. If it's similar, that means what? The element is not in that part of the list. We have to check to the right of it. Like for this example, if there were something like this, that at this index and this index was same, that means what? This condition was satisfying. That means the single occurring element was after that. So that's why we have to move the middle to middle plus 2. And why plus 2? Because let's suppose we were here and the next element was same, so we don't need to consider this element. So from mid to mid plus 1 plus 2, from here we have to check again. So that's why we were doing the mid plus 2. And else, that means what? Single element is occurring before that, that's why mid minus 2. And why minus 2? The same logic, because they were same, that's why we have to just skip one extra element, so that's why minus 2. And else, if the index was odd, then we are checking with the previous value. Like for this example here, if the index was odd, like for let's suppose this, here the index was odd, so if the element before that is similar to this or not, no, it is not similar. So that's why this condition is not fulfilling. So that's why we have to check where after this. So that's why we are doing mid plus 1, and else we are doing the same, we are checking to the left side. So that's why mid minus 1. So this is just standard binary search code. The main tricky part was this 2 line, where we have to check mid plus 2 and mid minus 2, and this condition like for this even odd and odd even. This was the main observation of this problem. So let's run the code and see if it's working or not. As you can see, already it's accepted. So let me just try it once again for the sake of showing for this video. And this is accepted. So just because we are using binary search, so the algorithm takes order of logn time, which was required for this problem, and we are not using any kind of extra space. So it is constant space complexity order of 1. So that's how we have to solve the single element in a sorted array problem. Thank you for watching. Do stick around for more, and please do not forget to subscribe to my channel. Thank you.